Hello, I'm BlueBearZone21 and this is video number 4 of an ongoing series where I'm building my own programming language. Today, we're implementing variables and pointers. Sorry I haven't posted in a while. It's been over a year since my last upload, in which time I have built the entire software for this twice, learned another programming language, that being Snap, and got a deeper voice, finally. The footage you're seeing is from the previous Python version of the interpreter, which is now depreciated. However, the design and systems implemented in this version still appear in the final version, which we are going to see here. As you can see, when you import a file, it prints out just like it was previously, and ignoring the I/O problems that the console library I wrote has, which kind of takes a while in this recording to deal with. But once that's fixed, we're going to be able to see two variables being made. There we go. The first variable, x, is allocated using the al command, which allocates that many blocks of memory in the heap, and then returns the first block of memory's pointer, which I am storing within the x's pointer. Same thing for y. Next, I'm going to set the values of the variables. For x, I'm going to set it to 10, and then I'm going to multiply it x itself by 4, which gives us the value of 40, and then I store it back into the x variable. You can also store it into other variables. I'm just doing this for test. Here it is with the value y. And a nice feature is if you put a dash instead of a number, or instead of a variable name, it's going to run the calculation, but it's not going to save it anywhere. Useful for the REPL to see what value something would be. Here I'm setting some values for y, and I also set it to the pointer first and demonstrated the fact that they are indeed pointing to the same location in memory. You can also do calculations without any variables, which is what I showed at the end. So here's how the code works. It's written in Snap, this really cool educational and visual programming language designed by UC Berkeley. And the code sitting on the right side of your screen is essentially the main function. Below it, I have a debug flag, which when I activate, outputs debug information like the abstract syntax tree for a function call. And the nice thing about Snap is that you can actually set this and unset this on the fly. Going into the REPL's code, as you can see, it's essentially just a wrapper function, which we'll see when I scroll down, and a bunch of other things to output information about the program and exit the very interpreter. At the bottom here, the final else if clause is the actual REPL code itself, which if we go in and look at the eval line, it contains several sub-functions that it calls. These are the system to set it to a value, the system to parse the function call into an abstract syntax tree, and the function to evaluate an operation. Going inside, as you can see, setting it to a variable is really simple. The heap is essentially just a list, and the variable list is essentially a dictionary. Opening the parse variable names, you can see that the code is really simple actually to parse a variable and figure out if you're referring to a pointer or the variable itself. Same with calculating values, though it kind of looks like a jumbled mess. Yeah, that's functional programming for you. and op, which uses Lambda to do the operations now. Much better than the old operation system that I wrote in Python. The final bit of code that we're going to look at is the parse command, which is also really simple, as functions in Berry are very simple in their syntax. I'm going to close this because all these pop-up windows, because they are really lagging out my computer, but yeah, that's Berry version vid 4. You'll find the link to this program in the description.